Hey, what's up, everybody? Welcome back to another 3D Hangouts. This is live. I'm Noe Ruiz, designer here at Adafruit, and joining me every week, Mr. Pedro.
What's going on, everybody? I'm Pedro Ruiz, creative tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
This is the live show where we combine 3D printing and DIY electronics to make inspiration projects for you folks. This is indeed live. We are streaming this live. It is Wednesday. Just a quick programming note. We do the show every Wednesday at 11 a.m. Eastern Time. We are streaming both on Facebook and YouTube. And welcome everybody in the chat room. This week's coupon code is Guardian, not from Guardians of the Galaxy, but Guardian from Zelda Breath of the Wild.
Which actually we need to check out. I saw somebody on Instagram mention Adafruit. They use a ton of Neopixels in one of their hallway scenes.
Oh, for Guardians of the Galaxy?
Yeah.
Okay, yeah, that's kind of neat.
I gotta find that posting. It looks super cool.
Great. Welcome everybody in the chat room. Thank you so much for joining us. It is live, so you're going to see problems, you're going to see mess ups. My audio is never turned on. I'm still fighting that. So if you do want to pick up anything in the Adafruit shop, we got a discount for you. Just use coupon code Guardian. How about we jump into this week's project? It has to do with Guardians.
Yeah, so this week, if you've been following me on my Instagram, you can see the progress of me building this nice big sword. It is the Guardian sword from
It's one of the
Zelda.
Guardian swords, yeah, from Zelda.
There's a couple, yeah, but this is one of the hardest ones to get because none of the weapons actually last that long in the game. So hopefully this one will last a lot more longer than it does when you're battling some of the Guardians in there.
Yeah, a lot of the weapons in Zelda Breath of the Wild, the ancient ones and the Guardian swords, they're all like perfect for Neopixels. And this was one of the ideas, was like, Pedro, you got to make, or I wanted to make it, but Pedro had the cycles in order to do it, so you put it together, so thank you for that.
Yeah, so it is 34 inches or 860 millimeters big. It's 6 pieces that are held together with M2 screws, and we have a trinket on the inside with a LiPo backpack to handle the recharging. We have a 2200 milliamp hour cylindrical battery on the inside. We have ports you can easily reprogram or charge this nice big old bad boy, and then you have the mini skinny Neopixels inside here. This is what's actually making all of the projects come to life, because before, when we had the bigger, wider Neopixels, it was a lot more harder to make something that was nice and slim like these are. It's only it's like 12 millimeters, 15 millimeters thick, and it's about 2 pounds, so it has some heft to it.
Of course, yeah.
But what I really like about this is it's not fragile. The last light up sword that I made was the Halo energy sword.
Yes.
And that one was actually glued together with like hot glue. The sides were put together that way. This one, because it's made or held together with machine screws, you are able to swing this guy around. It does not feel flimsy at all. Like you actually beat somebody.
You could probably beat them, which you shouldn't do. We don't recommend doing that.
Yeah, don't do that.
But a lot of interesting techniques used in this one, from modeling standpoint and both from kind of like just optimizing with electronics in there. Cool.
So obviously in the game we had to actually get it first before we could get some of the reference images to make all of the detailed parts for this. So that took quite a bit. In the learning guide, we say exactly where you can find the sword.
There's plenty of guides out there on how to.
We actually had to go out and buy the book, the strategy guide.
I did. I thought so. Yeah, I thought I was going to get some nice reference images. No. I couldn't find any references other than just getting it in the game. So
it actually was handy because there are scattered in different temples.
It's wielded by all the Scout 4s, and they're just all over the map. So it's one of those test of strength shrines. So you do have to battle.
It's pretty difficult to get.
All right, so let's take a look at the guide so we can get a little bit more close look at the
transitions
and stuff.
Oh, I did it too late.
Yeah, so the intro just kind of talks about the parts, you know, how long it is and stuff like that. We'll talk about how you can fit it on the bed. So just a handful of parts: Adafruit trinket, the 5-volt version, a USB charging circuit, which we call a LiPo backpack, a LiPo battery. This is the cylindrical kind. I like these batteries because you can drop them and they won't explode. That's nice. They're very sturdy and strong. Yeah, so you don't have to worry about it kind of being punctured really. A slide switch. And that's kind of it. The Neopixel Strip, again, it's a medium density. It's the mini skinny Neopixels. These are half the size of your regular Neopixel Strip in terms of width. So those are nice. Handful of tools. Screws, a lot of screws. So many screws that we had to label them properly and link them so that you can actually get them, because there are specific sizes for these, for putting everything together. Let's go to the circuit diagram. Very, very easy, simple circuit diagram. You're connecting the LiPo backpack to the trinket via 3 cables. You have an on and off switch. The battery just connects directly to the LiPo backpack, and then just 3 wires for the Neopixel Strip.
Yeah, the difficult thing about this is having to share the ground and the power connections with the Neopixel Strip and the LiPo backpack recharge circuit on there. So that's the only difficult part about this. Now, I didn't want to do the trick where we cut up the flexible PCBs to add additional pins, just because it would have been more cost to the actual whole project, and this makes it a lot more compact as well. So pretty easy to do. The through holes on the trinket are large enough to fit the 2 30 gauge silicone coated wires in there.
That's right. Cool. All right. Here's the code.
So we take a look at the code.
Yeah. So this is using sort of. We walk you through installing the Arduino IDE, installing the trinket profile, then you got to install the Neopixel library. We walk you through it because there's a little bit of extra stuff that you have to do, but hey, that's what you have to do. Real kind of simple thing in the code is I just took the Neopixel simple sketch. So the Neopixel library comes with a bunch of kind of demos that you can do, and one of the demos is called Simple Sketch, and what it does is it just uses a for loop and says all the Neopixels in your strip that are defined in the object, you can fill them up with a certain color. So I duplicated that for loop 3 times and just added these little guys here, color segments. So I have pixels A, B, and C, and then I'm just saying how many pixels are in that segment, right? So it starts off with 14 Neopixels. Those are orange, and then starting from 14 to 84, they're blue, and then we actually go back to orange starting from 84 to 93. So there's a total of 93 Neopixels in here. Mm-hmm. We counted them individually because we wanted to make sure to get that it covers the full length of the blade. I
do give you a size measurement too. If you just want to take a tape measurement and measure how long the strip has to be, you can do that as well.
But you can totally fudge the numbers if you want to offset it a little bit.
Oh yeah.
But it's very, very straightforward. This may not be the most optimized way to do it, but it's digestible. So at least it's not like every single pixel laid out saying like this is blue, 3 is blue. It's a nice use of for loops. So pretty simple. You can change the colors around or use this in a different sketch if you want. So it's good. You can obviously if you wire it to a different GPIO pin, just make sure your code reflects that. So that's it there for the code. As far as the 3D printing, you can download all the files from whatever repo site you like best. We support the top 3 here. Pedro has the design up for grab, so you can grab the source file. It's designed in Fusion 360. You can download it in any format. Mm-hmm. So you can edit it in SolidWorks if you're a SolidWorks person, or Onshape if you like Onshape, or even Tinkercad if you like Tinkercad.
You should be able to import it in Tinkercad, yeah.
I can foresee a lot of people doing that because it is designed for a 12 by 12 inch bed.
Yeah, a lot of people.
It's pretty massive.
Yeah, I think the majority of people might have like a 6 by 6, like a printer boss simple, or
10
like
by
a
10.
Flash Forge.
Even 10 by 10 isn't enough.
So you are gonna have to chop this up. I didn't get around to doing that just because these parts take like 36 hours of print. I had to move on and get all of the other shots that I needed to get. So they are up to 6 parts here, but you can get the Fusion 360 file and adjust where the construction plane that splits all these up, and the sketches for all the little tabs that hold all of these screw holes together. You can add additional ones to each piece that you split up. So you still can edit all of that, and of course go through the timeline and take a look at how the lofts were adjusted and how the paths for all of that was drawn out. Cool. You can take a look at that. So they are 6 main pieces, and then 4 other detailed parts, which are the overlays that create the nice little.
It kind of blacks out some of the lighting so that it resembles the details in the game. Mm-hmm. So this is really cool. Other than not a lot of glue, which I'm really happy with. Those tabs is a really kind of nice thing.
That was how I'm going to be making.
There's so many different techniques to kind of attach parts together.
Like
I'm a fan of screws.
Dovetails.
Yeah, you got dovetails, puzzle pieces, or skinny sticks where you add a stick for alignment and then you glue them later. This was a nice way to do it because it really makes everything sturdy and that much better.
Exactly, yeah. And If you ever need to travel with this, like say if you want to take it down to a cosplay event or whatever, travel with it like overseas or something like that, you can break all the parts down and it will be, as big as your biggest part, and it's like 6 inches by whatever, 12 inches. So you can get all these down. Of course, all the components can, be all nicely wrapped together. This will fit pretty snug into your luggage or wherever you're traveling with.
Cool.
So it's a nice way to have that be rebuilt.
Yep.
The top tip with this is using a printing surface like PIE or blue painter's tape or Print and Z plate to print this on, because it will give the material a matted look, which is excellent for diffusing all the lights. So my first attempt at this, I just used a glass bed, heated bed, and you could see the hot spots on the bottom blade there. You are able to notice those a lot more better. In real life, on camera, everything looks really good. But in real life, you are able to see the hot spots for where all of the Neopixels are on that. And then the top one, where we printed it on the blue painter's tape, you get a much better even distribution of the light, so you see that a lot less. Of course, you can take the one that was printed on the glass bed and do like sanding to, to get it to be as diffused as the one that was on the blue painter's tape, but that's extra processing work that I just didn't want to do. So right off the bed, you can get a very nice diffusion that way. What's so funny?
This is the comments. This whole show will be about fidget spinners. No. Sorry, tangent on that one. Cool. It's not just blue painter's tape. PEI, I believe, will give you a nice matted look. Print and Z, Build Tack, those are all great choices.
Those should do a really good job of creating that matte look on there.
So Pedro, blue painter's tape, what's your favorite blue painter's tape? I hear you have a jumbo size.
Yeah, so a lot of people don't like it because they're probably used to something like this, where it will curl up and come off. So I never use the smaller one. We have these big old giant rolls in the shop where all I have to do is just put down 2 rolls of this on the 12 bed, and only 2 pieces of this is big enough to cover the entire
it's kind of big.
area. Oh. So if you want to pick these up, these are actually pretty hard to source. When we're having Mary look for where to get these.
They're kind of pricey.
They are actually cheaper than what when I first looked for these guys. Yeah, well, because we buy them in such a bulk.
$50. I mean, it's a big roll.
It cost me like $60, I think, when I was buying these before we had them in the shop. Yeah, so
60 yards. What's a yard? Anyway, this is a great option if you're down with the blue painter's tape. We have some in the stock just because we kind of need some.
The number one thing that I use, if you guys saw the Time Lapse Tuesday, on the Ultimate Get Through, parts always fly off. Even with the bed being like at 70 C, it still flies off.
It will give you a little bit of a texture as well.
Yeah, which obviously for this project is exactly what we need.
It's good to have multiple build surfaces, so you get a different finish for all your parts. So this one worked out here for diffusing the lights. So okay, that's good. Some slice settings. These are slice settings that worked for the Type A Machine Series 1 Pro. For Simplify 3D, one of the challenges here was to get your tool paths in a way that kind of worked for your part. So you had to kind of play with the layer, the line width, or the extrusion width.
The diameter and the extrusion width to get this to play nicely with having a parameter in the middle of it. So it's just 3 parameters that are making this up. So usually we adjust the model to sort of fit what the extrusion and the diameter size is set. But for this instance, because we're limited on space on the inside of the blade, we wanted to make sure that I didn't increase the geometry any on that to bump into any of the other components that are inside there. So that's why I had to do that. So you always want to play with that if you absolutely have to have that size of whatever geometry you're trying to print.
Correct. Okay, and then Michael in the chat room is asking, how does the tape change the opacity?
The texture that is on the blue painter's tape is what's doing that. So on a glass bed, it's nice, flat, even.
So you get more transparent.
You get a more cleaner, transparent, like glass sort of look. If you can see the blue painter's tape, you can see that there's a bunch of texture on that. And that's actually what's helping it stick to the painter's tape, the little texture that's going on there. The material, as it's molten, it sort of seeps into there and it sort of grabs onto it a lot more better than a flat glass surface would.
Cool. So if you do want things a little bit more transparent on the first layer, Glass is probably your best bet.
Yeah, it just depends.
With regular PLA. There's other things like T-glaze and nylons that you could check out, but this is more just regular PLA. Okay, thought that was worth noting. All right, so back to kind of the layer widths and the extrusion width. Yeah,
so for me, it worked out for a 0.4 millimeter nozzle. I changed the nozzle diameter to 0.34, and then the extrusion width was set to 0.38. And that was enough to get simplified to 3D to make the tool path exactly how I wanted it to be.
I noticed here that it says infill is 10%. Now, because this is a shelled out design and it's thin in some respects,
so it's like almost 2 millimeters.
There really isn't much infill needed here because it's just solid perimeters and top and bottom layers. That's all what this geometry is. It's just walls and top and bottom layers.
That's another thing that I did not mention. I do have 5 top layers and 4 bottom layers, I believe, just so there's no infill that's being created on the bottom.
That'll show through.
It will definitely show through. Design. You'll see like all the infill patterns in the inside of that. You can
kind of see them here a little bit, I think.
On the sides, you can see them just because that's where the infill is, but for the sides of it, it's just solid.
Right.
That's what's attributed to the strength of this, especially down here where they're disconnected.
And the standoffs too, they're just solid perimeters. There's no infill in them.
Yes, you do not want any of that zigzagginess happening for the,
so it's pretty wall strong.
Gap. Yeah. It's really strong. Yeah.
Cool. So because the parts are so long, but they have a short width, long length, short width, you can actually make it bigger than the bed. So these pieces are actually bigger than 12 by 12. And the way to print them is to just print them diagonally at a 45-degree angle, right? So you have to orient it on your bed. Even though your bed's huge, you can get away with printing an even longer piece, shorter width, by just making it diagonal, because you get more room when you go diagonal. Cool. Support material. There is a little bit of support material required for these specific parts, and we kind of show you where the best placement for them is. It's mainly just the part where the blade connects to the handle, so you do have to add a little bit. We found a pillar resolution of, I believe, 4 millimeters is good here, and another thing is to kind of update the inflation layer so that they're one single kind of perimeter that makes up each individual support pillar. So that works out really well.
So what it's doing is combining the pillars together, so it's one continuous extrusion instead of like wasting cycles on retracting, going over, then extruding again. So it just combines everything together, and it makes it easier for removing the supports afterwards.
Yeah, these were manually placed as well, so that's another great thing we like about Simplified 3D is the manual placement of these supports.
Yeah, something like Cura would put supports on all of the little channel grooves on there, which would be a nightmare to remove, and it's going to definitely mess with the snap together parts for when you add the detail pieces inside of there. So you definitely want to have custom supports built inside of there.
Okie dokie. All right, support removal. Pretty straightforward.
Easy. We just use the flat pliers that we have in the shop. What we do is we stick the needle nose part of it in between the zigzags, squish, do a little twist, and then remove the support material.
If you find that your support material is
fusing,
there are some settings that you can play. Specifically in Simplify 3D, there is vertical separation, I believe what it's called, and there's also dense layers that you can disable. So those are some options that you can use to kind of give more separation from the part to the support material.
Yeah.
Obviously, the more support or the more distance you add, the more kind of droopage you can kind of get. So you got to get in that nice sweet spot.
I think for a 0.4 millimeter nozzle at 2.5 layer height, I think the top that is safe to do before it starts drooping is like 0.4, 0.5 for the separation.
Cool.
The vertical separation for the supports.
Right.
Okay, now moving on to the assembly.
Yeah.
So we are using the mini skinny Neopixel, the 60 per meter. So when you order this, we recently posted a video on when people order the Neopixel strips. Sometimes they're confused if they order like a 2 meter long strip, they might get just one roll, which is 2 meters long.
Yes.
So you definitely want to do that.
Yeah, when I ordered this for ourselves, I put 2 here, and we got 1 continuous roll. So it's 1 roll, but with 120 Neopixels, because it's 60 LEDs per meter. Right.
So sometimes we run out of a complete roll, and you'll get 2 of them. In that case, you are going to have to solder those 2 together to complete the length needed for the blade.
And when you're doing that, I can't recommend this more. Helping hands, third helping hands, get 2 of them. That gives you 4 hands.
So,
because then you can hold it in place while you solder these delicate pads together. Right?
Yeah. Well, not just that, because they're so long, they're gonna flop all over the place. So you need something to anchor them down while you can tin and solder. And in this case, you're gonna have to remove the cables that come with it, just because they are like 24 gauge. I want to say they're thicker than what we use for this project. So we're using the 30 gauge silicone coated wires because they're nice and flexible, they're thin, and they can withstand a lot of heat.
Yeah.
Just you're looking at a shot there of when I had to solder 2 strips together.
Yeah.
So what you do is just heat up one side and then slide the solder across to connect those 2 pieces. Just make sure that the arrows that are on the PCB are all pointing in the same direction.
Yeah. So the data flows
That's
in
the
a
way.
chain. Okay.
Yeah, the data flows, yeah.
Cool.
Next thing.
Silicone coated wires. Silicone cover stranded wires. Super long name. These are great wires. They have a good heat resistance, so they're not going to kind of, when you apply heat to the wire, it's not going to like curl up or anything.
Shrivel up, right?
Shrivel up. There you go.
So
these are
every project that we use, if the component already includes a wire, like say like the speaker for like
take it off.
girls, immediately take them off. Yeah, because they probably are not going to come with a very fancy silicone wire already on there. So
well, this is wire lengths. You need a longer wire.
You always need a custom wire length. Yeah,
Oh.
that's the second reason.
So we tell you exactly how long the wires need to be. These are kind of long, 144 millimeter long wires.
Yeah, just because they are at the tip or at the bottom of the handle, they need to come all the way up towards the top part of the handle because of the way that the layout is. So it starts from down here, has to go all the way up to here. That's why
I
it's so
recommend
long.
getting a spool instead of the little baggie with like a meter or whatever. I recommend getting a bunch of them.
They're pretty cheap. I mean, they're only $5, so
50 foot is what it is.
they last quite a while.
Yeah, and I would get different colors too, just to kind of for sanity check.
When did it say we last ordered that?
August of last year.
That's how long these have
We
lasted.
do it, and we use them every
single week. I think we have like more than half of a roll left, and we use like pretty long sections of it.
Yeah. So get some.
So they last a while for
wire.
$5.
Yeah. Great for flexibility. So good on strain relief and stuff.
Yeah.
So, okay.
Next,
You do have to remove the. Is that what you said? Yeah. What you said.
Yeah, you are gonna have to remove the tips on that.
All right.
Next
Side
thing,
switch.
Side switch. Yeah, you just remove the 3rd pin. You don't really need to. I mean, but if you want to keep it all nice and clean.
Yeah.
Again, don't remove the middle pin. That will disable the whole switch from working. So either on the left or the right, not in the middle.
LiPo backpack.
LiPo backpack. The first thing you have to do to prepare it to enable the slide switch to turn the circuit on and off is you're going to have to cut the trace that connects the 2 pins that's next to the 5 volt through a hole there. So we just use a hobby knife. Just be careful when you're handling it. Make sure it's like a fresh, clean blade, so you don't have to apply any force to try to cut that trace off. So just be careful when you do that.
Yeah. Pedro's pointing, and the blade is pointing to the area where you have to cut the trace.
Yeah, and if you click on any of the images inside the learning guide, you can get to the original size of these.
There's a bunch of sizes over here.
Yeah, so they're usually like 4,000 to 5,000 pixels, which is like
5K.
the original, the original size of what the photos
This takes
are.
a little bit. This takes like a minute or two to just chip away at that trace because it's a kind of a tough trace. Wow. Yeah. If anyone has any better ideas on how to cut this trace, let me know. I want one way to just go swoop and done.
Exactly.
It's not that easy.
Yeah, it takes a little while.
You have to damage the. You're gonna have
to like
to
sort
cut,
of dig into the PCB to remove that.
You're literally digging through the trace and then through the solder mask.
So that's the only tricky part about preparing the circuit for that.
And it's kind of dangerous. Be careful.
Bill Binko really quickly is asking why the trinket and backpack rather than the feather cost.
Yeah, we want to be this
size.
low cost, so you're looking about maybe $10 cheaper. Yeah.
Yeah. When people are looking at this,
They want the cheapest.
Yeah, so this whole thing costs $49. That is the same price as a store-bought
like, energy sword.
Energy sword, yeah, and it's
That's
going to be
60, but whatever.
Okay, well that's even cheaper,
yeah.
and it's going to be super lame. The ones that you buy like at GameStop, they have like 6 LEDs tops for that. So, and you're not going to find a Guardian sword right now.
Yeah.
So that's why we went with the trinket.
It's a little bit lower cost.
The form factor too. It doesn't look it, but it is pretty thin for the handle on this. So anything any bigger, remember there's more stuff inside there. There's the wall thickness that you have to think about. There's also the standoffs that are in here that also take up space. Which I had one like where you can open it up just to see how tight it is. It's the reason why I'm able to shake this around and you don't hear any rattling of the battery going around in there.
Right.
So that is the reason why we go with the trinket with a lot of the projects.
Yeah, the feather hussar is $15, but the trinket is $7.
Again, yeah. A lot of the cosplayers,
but the
they look at price.
Is $7 too, so it is $14 for the whole thing. You know. Yeah. Feather is a good
Again,
option
it's
too,
form factor too. Again, it's form factor.
All right, a little bit more smaller.
It's definitely more smaller.
Cool, moving on. Connecting the LiPo backpack to the trinket requires 3 wires. So it's a little bit more steps-wise, but that's what you pay for. We're in the low cost here.
Yeah, so you are going to have to share the ground and the power with the Neopixel Strip, and then the ground is shared with the micro backpack and the Neopixel Strip as well. So instead of using the flexible Perma-Proto to add additional pins to that, the 30 gauge silicone coated wires are small enough to stick both of them inside the through hole and then apply solder to connect those two together.
Another great use of 30 gauge silicone, right, is wires. So you can do this. You can fit multiple wires with one pin. So do it for the ground and the power.
Yep. So definitely just lay them in there and then solder to connect those two pieces. Then moving on to mounting the circuit, the trinket uses the M2 4 millimeter long screws. You can use 4, but I only used 2 on there. I just used one on diagonally on each side. Holds them down really good. Let's see. The battery is then the LiPo backpack uses M2.5.
Right.
Now, there's only one on that. So it's easier to mount on there. So it's a M2.5 by 5 millimeter long screw for that one. And then the battery is mounted between the 2 walls that are holding it together. So before you do that though, you do want to route the wires around the little gap that we have on the wall there. So it can just string that. And you do that with the slide switch as well.
Gotcha.
Now before you mount any of these, you do want to make sure that there's no access material or overhang on the port openings for the USB port and for where the slide switch sticks out. So I did have that problem when trying to stick a USB cable in there. Just make sure to use a hobby knife to get rid of the overhang on the port openings for that before you start mounting it. The battery, the way that we're able to have it not rattle around is we're using the silicone wires as cushions for them. So you're increasing the thickness of it by having the wires be underneath the battery when you mount that. So just make sure to manage the cables in that way where you can put them underneath the cylindrical battery to act as a pillow to cushion it and make it nice and strong when you're swinging the sword around. The slide switch, as I said, it just pops into the 3 walls that hold it together in place. So it's really easy to do. Just insert it at an angle, and then you can use something with a flat tip that'll allow you to sort of push it into place, and that should be good. Next up, for actually adding the Neopixel strip to the inside of the blade, if you scroll down just a little bit.
Where? Sorry.
Adding the Neopixel strip. So we're using double-sided Nitto tape, which is really strong. Actually, it's strong enough to where you use this.
I love this stuff. Yeah, I love Nitto tape.
You use this for all your CNC stuff.
I use it for all my CNC stuff, and I use it for sticking strips to tables and other things like that.
But
Works
not
really
only
well.
that, metal, like metal blocks
metal.
or wood,
Looks good for metal.
wood blocks when you're seeing pieces of material, it's strong enough to hold those in place. So it's definitely really good for holding the Neopixel strips. It adheres really good to the silicone sheathing that's on the strips. Gotcha. So you can just strategically place these around the inner curvature of what the little trace design for the blade is, and you want to face the Neopixels back to back so that the LEDs are facing outwards. If we jump into the...
take a look how the strip kind of follows the contour. You don't need that little black wrap around.
It's just a little
tie.
It's just a twisty tie.
Yeah, you really don't need that, but it kind of helps a little bit to keep it kind of straight there.
Yeah, just if your Neopixel strip is being stubborn and not staying
So the
down.
tape will just keep this, here. And obviously you can see that the Neopixel strip is vertically mounted, not flat mounted, because that's the way the light spreads out. And it's cool that the sword has this trace blackout that's supposed to black out the lighting, because that's a perfect place for the Neopixel,
exactly.
right? So that worked out really well. And then it splits around over here where it goes into the handle.
At that,
so that worked out well. You could get a little bit more. I think in the second version, it followed this line a little bit more and had a sharper corner here.
Yeah, it did.
So you can be as detailed as you want there, and then that's where the strip ends up. You want to leave the sheathing on for protection, and just because the tolerances are made for it, the sheathing. Without the sheathing, it'd flop around.
Yeah, exactly. The extra width that is on the side, added by the sheathing, is what's actually sticking it.
Yeah, it holds it together. Yeah.
So you probably want to turn on the circuit to check where the orange and the blue is, just so you could do some minor adjustments, like by a pixel or two, to sort of curve that around, so you're not having any of the orange bleed onto the blade part.
Right. Yep.
Just some detail stuff you want to do there.
Yeah, and I like this. It's a little more elegant, because you could have multiple Neopixels, but you would have to wire them to different GPIOs, and then you'd have to make multiple objects in the code to say what pixel color should be where. So this is kind of a neat way. Just use one strip, and then just use different for loops to say this range is this color and this range is that color.
Yeah, I was going to go this totally wrong when I first was sketching out how to build this. I was going to have individual sequins do this. I was going to have like
I kept telling you, that is a bad idea. Stop, don't do that.
It would have had hot spots all over the place. This way is a lot more efficient. I don't have to have additional. I was going to have a jewel where the little gem part of the handle is.
You can get as detailed as how long do you want to work on this, right?
Yeah, exactly.
Like, you kind of need to get this done within a week or two. Yeah. And I'm glad you did it in a week or two. So that was great. A week of 3D printing.
So after all of that is nicely mounted, you'll need to combine both halves using M2 millimeter screws that are 12 millimeters long. Yeah. So I actually got the idea for building it this way when we were taking apart one of Gavin's toys. Yeah. The standoffs on one side of it was like a dinosaur bubble gun. On one side of it, there was like, the standoffs were way longer than what the whole part was, and that's what gave me the idea to go, oh, okay, I can, because I was thinking of already gluing this together.
It's just a standard thing to do for things that are injection molded. They have these long standoffs. Yeah. One thing though is that they're not countersunk. So countersunk being that the screw would go inside of it, and you would need this extra geometry around that standoff in order for the thing to sink through. Exactly. Hopefully visually that makes sense, but.
Yeah, so the thickness of the size of it, it's only 1.4 millimeters, so I just didn't have the space to actually add something that was countersunk into there. It's pretty thin.
There you go. Here's your
standoffs. But there is a chamfer on this so that the screws are flushly mounted to the surface. So I did have enough space for that.
So these standoffs exceed the height of the half, as you can see here. Standoffs.
It's about a little.
And again, they're just perimeters. There's no infill there. There's a little bit of a chamfer too, so that they're a little bit thicker at the bottom. Oh wow, it's starting to be delayed. Interesting. All right. So you need long screws. So there is one half that doesn't have holes, and the other half does have holes. So this is the good half.
Yeah, the other side has the. You can see it there. I didn't clean this part up yet, but
we've got a major lag going on here.
Oh wow.
Let's just be aware of that.
More easier to see, yeah. So there is like a 1.5 millimeter chamfer that is allowing the the screws to mount flush on the surface here.
Okay.
And the last couple of steps is adding the detail to it. So at first I was like painting these in, like masking out the parts to have the brush fit inside the channel groove to add that detail in there. But that was way too time consuming. It only takes like 8 minutes to print out the little detail parts. So I went with that instead. They're like 1.4 millimeters thick, so it prints really fast, and they just snap into the channel grooves of the detail, little trace detail. So you just snap it right in. And,
Bill has a great option here. Is that you can actually tell the pixels to turn off, and that way you can get a more separation. It's a good idea. So you can actually tell a specific pixel to just not be on. That way you get more of a separation.
And that is more efficient in terms of battery life as well.
I think so, yeah. Huh. And battery. Speaking of battery life, folks are wondering, what's the battery life?
Maybe 2 hours, I want to say, something like that. It is only set to half brightness.
Right,
but
and they're not animating.
Yeah, there's no animation going on, so there's not.
So you probably get a little bit better.
Yeah.
There's some of the best ways to do it is to just kind of turn it
leave it
on
on
and see what happens. So it's been on the whole show, right?
Yeah.
All right.
So it's sitting there. It's a couple hours.
I hope so.
Yeah.
We'll see. We'll let you know. At
and
the
if
show
you're
and
gonna
tell.
take this to a con or something,
Turn it off.
again, very helpful to have the charging port down here, because you can just have the wire going down into a battery in your back pocket or something. So pretty easy to keep this powered. One thing I keep forgetting to mention, I love how this little hook here is able to have this easy mounting like to a wall, or in our case a shelf here. That's a cool little design detail on that. So after those are press fitted in place, the last thing to add are the little gem parts that are on the upper part of the handle. Those just snap fit right into place.
Great.
And then you have yourself a fully complete Guardian sword.
That's great. Cool.
One of my favorite cosplay projects, because all of the swords that I've done up to now, none of them had light in them. The way that they were assembled was with the skinny sticks to combine all the pieces together. Using the screws on the inside with the tabs is definitely the way to go. It increases the rigidity of the project really good. As you can see in the video, I'm sitting there swinging it around, and it's so fun to do that. Yeah, especially with none of the swords up and now have been like sort of what the essence of Adafruit is, having your project light up, and this one definitely accomplishes that goal, and you're able to really use it if you want to.
Don't hit anybody with it.
Yeah, it will hurt. So if you guys want to pick up any of the components used to build, you can use coupon code GUARDIAN to get 10% off the printer that we're using for this.
Yeah, we actually looked at it. It's a pricey printer. It's huge, but you can get $400 off if you use that 10% discount. And if you're in the States, you get free shipping.
Yes.
We have 2 left.
Yep. John Park just got one and is absolutely floored on how the quality that you're able to get out of this printer.
Yeah.
It's,
well, the size, all the helmets and things and chairs.
For his Lucio blaster, I had to print a bunch of the bigger parts because his Ultimaker just doesn't have the space to print all that out. And you're able to go 90 millimeters a second, and the surface quality on that looks excellent on that. It's able to handle like every material that we throw at it, as long as it's 1.75 millimeter diameter. Yeah, the Ninja Flex prints on it phenomenal.
Yeah, I'm surprised you could just feed Ninja Flex in through the direct drive, because normally, like with the Flash Forge, I kind of can't extrude like that,
No, you can like feed it in there as you're holding the spring arm, and it pushes right in there. Right. The cool thing about it is it's just one screw to lift the cover that's holding the extruder together, and you can see it's just literally a nozzle that goes into just a tube that goes right into the heat block and into the nozzle. It's like all combined, so it's a really good design for that type of stuff. So they're usually on printers, when you're changing colors, there's like some color left behind on the outer walls of the heat break. Yeah. This, like as soon as you put another material in there, it immediately changes color. Yeah. So it's a really cool feature of that.
Barry has a great kind of tip here. If you are using machine screws, a good option is to get yourself a set of tapping
Yes.
What is it called? Just taps?
Yeah, we need to get some taps. But the tolerance.
Oh, self-tapping screws. There we go. Yeah.
Okay.
These have that. Probably have like a tip or something that's specialized for tapping it.
Okay. So the tolerances that I have for the standoff are in such a way that the layers actually create the threads for them, because I'm using a 0.25 millimeter layer height. It actually does a really good. They're practically printed with the threads in them because of the layer height.
Right.
So
good thing. Yeah.
It was a really that was by luck. I won the maker lottery on that one, where it like it printed tapped on there.
That's good.
So there's no like forcing to create the threads, which is something I should have highlighted, because I was like super surprised and happy when I was able to just screw that in there without having any force. And this is on all the mounting holes on this, so there's no like pressing it in there to create the threads.
Okay.
They just go right in there and hold on really tight.
Cool.
What else? Oh yeah, the silicone coated wires, the material that we're using, of course, very much loved giant roll of blue tape. You can get discount on all the stuff. Use coupon code GUARDIAN. It'll last until 11:59 p.m. tonight. If you guys want to order some materials, components.
Jim has a great comment here. He says you can add an accelerometer and a speaker, so when you lift it over your head, it makes that.
I know we did. I know we thought about that.
Yeah.
After we were done shooting, like, oh, we should have added the.
I think that'd be a great upgrade to it.
Somebody wants to take it on,
yeah,
definitely.
Because sort of the foundation is there, so adding more components is can be a little bit tricky, you know.
There might be some space over in this area here.
Yeah,
might be space here, around here. Yeah, I mean,
good spot for the speaker. Maybe it's a little small.
That would be excellent. Yeah,
Right
here. Yeah. I was thinking at least the.
Yeah. Okay, cool. Great comment. Thank you, Jim.
Yeah, definitely share that if anybody takes that on and adds any additional components to it. I'd love to see, share.
Very cool. All right. Well, that's the project this week. It's a lot of fun putting it together.
Super fun, yeah. Super fun to shoot. Had a great time figuring out those new techniques on combining the parts together. And of course...
do you want to talk about the things that went wrong real quick? No.
Yeah. So
everything that could go wrong kind of did go wrong with 3D printing. Printing large things is very challenging.
Yeah.
Your filament can run out.
Your nozzles can break on you.
Nozzles can break.
So I did lose 2 nozzles in the process of printing this out.
Show us the nozzles.
So these are older nozzles that came with the Type A. They've since upgraded them, but I'm gonna say that something probably became loose, got caught, and then just got ripped off like that as the bed was.
So they're more stronger. The head. If you get one now, they're definitely more manufactured better.
Mm-hmm. Yep.
All right. Well.
So this one's a goner. I already ordered some. Having additional parts for when you're like on a deadline is definitely a saver. Right. I had more nozzles of this, so always make sure you have extra parts, extra material, because I did run out of filament mid one of the prints. Luckily, that's why a lot of people stock so much filament. So just make sure you have extra material, extra nozzles. That's why we have multiple printers too. In case one goes down, you can continue printing.
I got a question here from Greg. Hey, Greg, who did the choreography in the video? Good work. That's just Pedro.
I just swung it around.
Pedro's a ninja. He's a black belt now.
I just swung it around. Yeah, there was no choreography.
Yeah, it's like, all right, do something cool. And I'm like with the camera.
Yeah.
Yeah. Not much planning there. Just let's go outside and see what happens.
Yeah.
So good job, Pedro. Swinging.
Thank you.
You could have hurt yourself pretty bad. All right.
What else we got here for the
That's a lot of stuff.
Bits?
That's a lot of stuff.
Yeah, if you want to know where to find or what shrines the sword, you can check out the guide. There's
plenty of guides on the internet on how to get the sword.
Well, you can get there ad free. It just tells you straight where to get it, where the map is.
Okay. All right.
You just have to be. You have to be all nice and armored up because The Scout is pretty tough to beat.
It's a major test of strength. It's in the name.
Make sure you have a lot of food, because that guy is going to beat you down to get that sword.
All right, well, cool. Real quick, you want to do, we're running kind of late. That's fine.
Oh, wow, that was the whole
show, no.
Okay.
Real quick, I want to show you guys what I've been working on. I do have a little bit.
Project?
Yeah. Oh, man, we got to run through this real quick. All right, so real quick,
we can
if you guys
save
want
stuff
to
for
see,
next week.
check out my Instagram account. I have a lot of progress happening. I am putting together this guy here, which is an integrated truck riser. If you're a longboarder, if you're a skateboarder, you probably know what a truck riser is. It just kind of elevates your board off the truck so you get less wheel bite. So this is an Adafruit feather, the Bluefruit NRF52, so I can change the colors. It's a headlight for your skateboards. It's integrated into the trucks. So that's what I've been working on putting together. This is a electric longboard, but it'll also work with regular longboards and probably skateboards as well. So that's what I've been working on, and that's actually going to be next week's project. It's kind of simple as far as circuits go. It's just a Neopixel stick and a feather and a switch and a battery. It is a little bit dangerous to put a battery in between trucks and the deck of a skateboard, but if you have enough infill, it can work with PLA. So I've been testing this on and off, and I haven't crushed it yet. Obviously, I tested it before putting the battery in there, just to make sure that there is rigidity and it's not going to like collapse on itself. So check that out on Instagram if you'd like.
Yeah, we'll show it off next week, but this is what is creating.
It's just an enclosure.
Yeah,
PLA. I'm surprised it didn't break.
So surprised.
I mean, if you're doing tricks, you're probably gonna break it, but I'm not doing tricks. I'm just cruising. So great way to get outside.
Yeah, it's the four little standoffs here that's creating the rigidity of this.
Yeah. 10 minutes left. All right. Quickly, shop talk. I don't have a video for it, so I'm going to show it real quick, and we'll show it next week. But basically, this is a 3D printed ergonomical holder for your Joy-Cons. This is for the Nintendo Switch. This was designed by our buddy Alex Hatch, who goes by Hatchman Pro on Instagram. So he designed this, and the real thing I want to take away about it is light pipes. So we're using a piece of T-glaze filament. This is nylon filament from the fine folks at Tallman. You can get this stuff at tallman3d.com, and this makes actually really good light pipes. So if you look at the Joy-Con, there are these little LEDs, and what you can do is when you slide it, there's actually a piece of filament in there. It's just 175. This isn't dual extruded or anything like that. It's just a piece of filament. You cut it, and then you can use your soldering iron, or you can heat up a flat spatula and then kind of flatten that out. So it looks a little bit dim here, but it looks good in person. I'm not sure why it's looking dim there. I guess the alignment has to be a little bit better. Yeah. And obviously you can put them all through the holes. It's printed with a little bit of support material. It works really well. It's just a teeny bit of sanding required in order to get the tolerances right. But hey, it works out really well. So if you got a Nintendo Switch and you're finding the controller thing that it comes with is a little bit not ergonomical, hey, that's why Hatchman put this together. So shout out to Hatchman. You can get this on my manufacturer, and I'll have it linked below after the show is done.
I've been wanting to do a light pipe project for a while now since we got this. Like, oh my God, like 2 or 3 years ago. It's been sitting there, still like almost a full roll of it.
So as far as like effort, it's just cut, put it in. It's very
flatten out the end so you can get the light pipe to work.
This will probably be next week's Time Lapse Tuesday, because it's kind of an interesting little print on the Z.
Very cool. I don't think anybody's done this yet for that. Definitely a good way to get the LED status for what's on the inside out to your little connector.
That's right.
Very cool.
Cool.
Excellent job there by
Alex Hatch.
Check him out. Follow him. He's been doing 3D printing for
as long as we have.
A long
since
time.
2012. Yeah. Great stuff.
Very cool.
All right. That was Shop Talk.
Next up, we have
I'm going to do Q&A.
Q&A, yes.
Yeah, we're going to have to close the show. All right. Have you thought of printing PCBs or printing with PCBs? I've experimented with conductive PLA filament.
We have a couple projects already. We combined it with NinjaFlex, so you are able to have flexible traces on it. I just made like some hands that have LEDs on them, and they flex really good. The traces we're able to maintain even while flexing. Noah's pulling it up here.
Yeah.
What else did I make with this?
A bunch of stuff. If you go to our product page listing for the conductive filament, this is from Protopasta, really cool guys. We have quite a few projects here. I used it on, you could use it on the Bluetooth MIDI controller. Here's Pedro's flexible glove that he's talking about, so you can interchange, or you can mix materials together, and we have a battery tester. And the NPR radio isn't here, but it should be, because I did use that as well. So this is a flexible kind of glove overlay thing, so you can definitely power a couple of not Neopixels,
Sequin
LEDs. Yeah, these are LEDs that are really small surface mounted LEDs that have a resistor built in, so you don't have to worry about an extra resistor, and then a coin cell battery. So there, check that out. I'll have that link below. Really great use of dual extruding. And I think you could just print it on top, or do you have to be dual extruded? It has to be dual extruded, yes.
Yeah, it has to be. So they are on the inside of the entire model, so nothing is on the outside except for where the pins need to come out to do the connections. You can see it right there. And on the top part there to have the ground connected to the
flexible PCBs.
The coin cell battery.
There you go. There's a good look at that. So.
Yeah, so we just use the Flash Forge Creative Pro. I give you all of the settings to use on that, and of course all the STLs to combine that together. Cool. And the battery tester as well is another cool one. In terms of printing PCBs, the pitch that you're able to get out of this is not as thin as using something like the other mill.
Yeah. I tried printing a sort of like what is it called, the Pygirl button PCB. That didn't work out well.
Yeah,
so you have to kind of make your traces and distance between the traces a little bit bigger if you're making a PCB. But it is possible. You can run low power circuits. There's also electrify filament, which is a little bit pricey, but it can power an Arduino, like a whole Atmel chip, which is kind of neat.
Yeah, so the only problem that we had with that is the melting temperature of that is pretty low. Okay. So it will ooze, and it did bridge some of the traces together.
Okay. All right.
Let's see. Bill is asking, is the conductive filament accurate enough for capacitive touch?
Yes, absolutely. Yes. It's great for capacitive touch. One of the demos that Protopasta put together is actually a little joystick thing. So I think for accessibility that could be really helpful, because you can design your own gamepad and there's no resistance or buttons. You just touch it, right? So yeah, so this is it right here. This is a dual extruded print on the Flash Forge. It's a little bit messy, but it works out well.
Works pretty good.
I think it was for the Makey. Yeah. So you just use alligator clips and connect those up, or overhead tape or whatever, the copper tape.
So the ground is right here where you would hold it. That's making the ground, and then when you tap the buttons, it'll close the circuit on that, like that. And this works really well, despite some of the smudging that you see from the oozing from the dual extrusion. This works very well.
Yeah, they have the resistance. They have the ohm resistance and stuff.
They have it
outlined in their data sheet, so you can check that out.
It's in the product listing as well. So this is why we couldn't do a PCB, because you could see how big these have to be in order for it to work. Right. But once it's something like this, it works really well. We use it on the NPR Raspberry Pi radio project as well. All the buttons are just touch like that. And you can extrude it, or you can have it printed separately, and then use the conductive bare ink to hold the wires onto all the individual pads to wire that into the GPIOs. That works really good.
That's right. Kirby did an example here. He's experimenting where you can actually do capacitive touch through the print itself if you have copper tape
on the bottom of it, or on the other side of it. I was really surprised on how well that worked. So that's another option as well. You don't even need to use the filament if it doesn't need to be routed in a different way.
Kirby, can you paste your link to your Instagram account so folks can see that? I think it's Kirby 81 or something. Kirby 81. Yay, I found it. Yeah. Do you have it on your Instagram? Oh boy. I'm looking. I'm not sure if you have it on your Instagram. If you don't, you should put it up there so folks can see. It's a great example of how you don't need to have conductive filament in order to do something like this. It's kind of like hidden buttons that you can do, which is pretty neat.
Yeah, it is.
Yeah.
But some things that you do need it for, like the battery tester, you can see how small you can get the trace to be to where it still works. And it's just a regular battery here. You can see when I clamp down on it, you can see the LED turns on. Can you see that from the overhead?
Yes, you can.
Kind of see it, yeah.
Oh, yeah.
So the trace is just going inside here, going around to the LED. And again, we're just using bare conductive. The pads are on the bottom there.
Oh, as a kind of as the solder, right?
As a solder, yeah.
But this is dual extruded
connection.
with conductive PLA.
Yep. So you can see there. It's white, so yeah, here we go.
Cool.
So it works very well.
Yeah,
with
Bill has as soon as the
M0.
M0 has the touch library, he's got a project for that, so that's great.
Ooh.
I think for accessibility projects, it's really good.
I can't wait to see that.
Yeah. Okay. Kirby said it's on Twitter, so he's going to post it. Cool. It's great. All right. Any other
What else we got there?
questions? Let me quickly run through them. I think Greg had a question about the phone of feather. I still haven't got a chance to get to that. As long as you have 2 mounting holes in the front, you should be fine.
Oh, for the phone.
Yeah,
Okay.
I did test this in extreme conditions specifically with the project I'm working on now, the integrated truck risers. I only have 2 mounting holes secured to the enclosure, and there isn't any vibrations. And I'm on concrete. I'm on gravel. Like, it's pretty good.
How did I mount the phone onto the Star Trek communicator? Go over to the overhead. So the Star Trek communicator, it's a real phone. It uses the phone inside. Let's see, how did I do this one?
Oh, it is.
Yeah. Okay, so I didn't use any screws at all.
Right.
I'm just using...
I think George has a more specific use. He's on a
okay.
boat, right?
Oh,
he
that's
might
right.
jostle around a bit, but...
If you guys want to catch last week's show and tell, George was on there showing
yeah, thank you so much.
Really
for
cool
showing
project
your
on
project.
that.
Very, very awesome. That was last week's show and tell.
Yeah, so I'm just using little standoffs that clip in there. And I even had to cut this one because of the way that the standoff...
Yeah, it's like the one that's just...
It's like so weird the way
Yeah.
that the mounting holes are for this one,
Yeah.
but there you go. Can be done without if you can do
it. It is
without
longer. It's the longest, one of the longest boards.
Okay.
Yeah. So it still fits in the box. It's just those back standoffs don't line up right.
Mm-hmm.
So, yeah. Okay.
Phona. Well, this is a Phona.
It is, yeah.
Yeah, this is a Phona that I'm using inside here.
It's a phone feather. He's just saying, oh, it's too long to fit in the box? Oh, in the TFT box. Yes.
Ah.
That is different. Sorry, I thought it was the regular box. So I think I can make a quick modification to that. It's still on my to-do list, and I'm getting to it. If anybody out there wants to do the update, it is parametric in the sense that you can update a user
Just the
parameter,
styles,
I
yeah.
think. So we'll see
Even
if I can
like
get that out.
even like
this
pushing
week.
and pulling the walls should be able to be good for that.
That's right, and oh man, I didn't get a chance to share the Community Makes this week, but I will be sharing it on the blog. Bill Binko did a nice update to the feather box, specifically to fit Perma-Proto half-size version.
Very cool.
I'll quickly show that real quick.
Should be
So
super
you can,
useful.
yeah, I have it open, I just didn't have time to kind of share it.
This will be on the blog though, but
Yeah,
we'll
this will be on the blog.
talk about it next week as
So,
well.
He's got the mounting tabs, and I think he added
Very
some
cool.
extra kind of
looks so
mono.
clean.
Yeah, it looks really nice.
Wow.
Good job, Bill. This is great. He's got the
Very
Cat 5
awesome.
cable in there, I think. Cool. You even put the AT logos on there so you can
That's so
brand it
cool.
yourself. That's really cool.
Very cool.
Great.
Excellent job.
Yeah. We need to work on the next one. Yeah, me too, the TFT one.
Something
Cool.
else I want to mention. Oh yeah, Kirby has posted his testing with the Capacitive Touch, where all he does is just put the copper tape on the other side of a box, and it works.
Booyah. It's a little Adabot. It's great. He's using the Circuit Playground. So as you can see, he's going to touch Adabot, and that changes the colors. So you can use.
Yeah, I wouldn't believe
copper
this
tape.
if there wasn't a video of
Yeah.
this. This
So
is
the
amazing.
capacity can be sensitive enough to reach through the plastic. And this is printed on the Z, right? So the layers are a little bit more challenging, I guess, to get electrons through.
No, but it works perfectly. So
Yeah.
if your application is similar, it should work really good for that.
Yeah. Fun. Didn't it work? There you go. Follow Kirby on Instagram too. He's done a lot of awesome projects.
There's a lot
He's
of really cool
contributor on the Adafruit learning system. Great Pi projects as well. He's got YouTube. Check out the YouTubes. All right. And
Oh, again, the chat always covers up anything that's over to the left. We have to adjust that.
there you go. So touching Adabot, not there, but right there where the copper tape is stuck to. And this is really nice copper tape because it is conductive adhesive as well.
Yes.
So the sticky side is conductive.
Yep, if you check out the product listing for that on the shop, you can see all the projects that have been used or utilized with the tape.
We got a. Is that? I think you have to sign for it, maybe.
No, it's Gavin.
Oh, okay. All right. Well, that's going to be it for this show.
Looks like my son's back.
Yeah. It's like overtime. All right, guys. Well, thank you guys so much for watching. Hey, Gavin, you want to be live on the show real quick? No? Okay. He said no.
Go say hi.
Well, this is what happens when you run over or go over time.
I know. We have a very specific time we have to get done. Thank you guys so much for watching. We will be on the show and tell later tonight at 7:30 Eastern Time. If you want to come and join us, please do go to plus.adafruit. Wait, what is it?
It's
Hi.
usually in the comments. Say hi. Say hi to everybody.
We don't have a cat, but we do have a child.
Look, he's Hulk.
It's Hulk. He likes being Hulk.
All right, go with mommy.
I see it. I see it.
We'll open it and when I'm done.
Thanks, guys. We will see you later tonight, and that's it. Bye, everybody.
Guys. See ya.